Okay, so today is the first video lesson of semester 2. So hopefully you all have access to Blackboard. I'm also posting this to my website, but in the classroom you can watch this through Blackboard. What I'd like you to do first is today's warm-up, which is directly off the published No Calculator section of the SAT. So if you guys could take a moment and give problems 8, 9, and 10 off this sample test. That's why they're numbered weird. We're starting with 8 because it's directly off a sample test released by College Board. If you guys will try these, and when you're ready to check your answers, you can press play. Okay, so let's take a look at these. Number 8, the answer is C. A simple way to do this problem would be to solve this first equation for A, and the way we would do that is multiply both sides by B. So A is equivalent to 2B, so wherever we see A, we can just plug in a 2B. Our B's cancel, and 4 divided by 2 is 2. Number 9, there's a couple different methods you could use for this one. This is a system of 2 equations with 2 unknowns, and we want to know the solution, which is the intersection. We can solve this using substitution or elimination. If you chose substitution, this second equation is fairly easy to solve for x. We can just move the x over here and the 19 to the other side. So all we're doing is changing the signs of these when we move them from one side of an equation to the other. So we know that x is equal to 2y plus 19, and then we can take that and substitute it in to the first equation. So we get 3 times 2y plus 19 plus 4y equals negative 23. And then we have one equation with one unknown, so we'll just distribute to solve. So this gives us 3 times 19, which is 57. And then we will subtract the 57 and add the y's here, so we'll get 10y equals negative 80. So y is negative 8, and my solution is B. If we plug back in negative 8, we will see that x equals 3. All right, number 10. For this function, d is defined as this. We should recognize this as a parabola. A is a constant, and g of 4 equals 8. So what is the value of g of negative 4? All right, so if g of 4 equals 8, that means when I plug in 4 for x, I get out 8 for y, which is g of x. So we get 8 equals a times 4 squared plus 24. So this is where I plugged in 4 for x, and I get out 8 for y, which is our g of x. And then we just solve this. And when we solve this, we get negative 16 equals 16a. So negative 1 equals a. So g of x is negative 1x squared plus 24. So what is g of negative 4? So if I were to plug in negative 4 for x, first thing I'm going to do with that negative 4 is square it, so it becomes positive. But then I'm going to multiply it by negative 1, so it becomes negative again. And negative 16 plus 24 is 8. Okay. The other thing we could use is what we know about parabolas. We know they're symmetric. So if the vertex is up here at 0, 24, which we can tell from this equation, it's been shifted vertically 24 units. It's symmetric about that vertex, the vertical line that passes through the vertex. So we should know that g of positive 4 is going to be equivalent in value to g of negative 4. So if g of positive 4 is 8, then g of negative 4 must also be 8. That's a much quicker way of solving that problem by tying it back into its graph. Okay. The next thing we're going to do is go ahead and check the homework from last night. So if you guys will take out your homework, and while you are checking, I will come by and check for completion. You can go ahead and pause where you need to pause, but what you must do is ask questions on the problems you don't understand. Okay, so I will be walking through the room now, checking for completion of the homework, while you are making corrections in red ink on the ones you missed. Since we're going back to lessons through Blackboard, this is something that could be on a notebook quiz also, so make sure you get those corrections done. Okay, so here's 13 through 20, and I have shown some of the work where you can see some in blue and some in pink, but if you need me to go over any of them individually with you that you do not understand even after seeing the corrections, please take a look at those now and ask me questions. When you are done making corrections, if you will flip to the back of your worksheet, it's more of the same, and I want you to try 13 through 17 before you start today's lesson. Okay, I'm gonna go through those individually in the video, so when you're ready to check your work, press play. Okay, so let's take a look at these. Now with this first equation, expression, there's a couple ways we can start. I like to move the negative exponents down, and so when we do that, we're left with x to the 5th, and I said down. They just move, if they're in the numerator, they move to the denominator. If they're in the denominator, they move to the numerator. Okay, so now this is what we have. All right, so now we can cancel 3 of these x's with 3 of those, and that leaves 2. Because these are being multiplied, we can add those exponents. So what we're left with in the numerator is x squared, and what we're left with in the denominator is 2y to the 16th. So if you have any questions about number 13, if you still don't understand, please ask me now. Okay, let's look at number 14. On this one, everything is being cubed. So a negative 2 is being cubed. A negative number to an odd power stays negative. So it's negative 8. A power to a power, we're going to multiply, so that's m to the 6th. And w to the 1st times to the 3rd makes w to the 3rd. All right, on number 15, it's straight multiplication, so 4 times 8 is 32. When we multiply like bases, we add the numerators, so 2 and the understood 1 makes 3. A negative 2 and a positive 4 makes a positive 2. And 3 and 2 make 5. All right, let's take a look at number 16. Number 16 is interesting because the entire numerator is raised to a negative exponent, so the entire numerator moves. But when an entire numerator moves, we got to have that 1 remaining. So we have the 1 there. And then all of this gets raised to the 3rd power. So you could do it in one step. 2 to the 3rd. Or we could, let's go ahead and write it out so we don't do too much at once and confuse ourselves. So all that's to the positive 3rd power now. So this is 1 over 6m to the 5th, w, and now all of this gets cubed. So 2 gets cubed, m to the 2nd gets cubed, power to a power we multiply, and the w is cubed. Now my final step is to go ahead and multiply. So 6 times 8 is 48. M to the 5th times m to the 6th. When we multiply like bases, we add the exponents. W to the understood 1st power times w to the 3rd power to a multiplying like bases, we add the exponent, so that becomes w to the 4th. And there is our simplified expression. Finally, we have powers here, and so we'll go ahead and raise these to the powers. Power to a power, you're going to multiply, so that becomes an 8. And now we're multiplying like bases, so we add the exponents. All right, if you have any questions about 13 through 17, make sure you ask. All right, the next thing we're going to do is move on to today's notes. And today's notes, we're going to be simplifying radicals, and we're also going to be switching in between a rational exponent, so an exponent that's a fraction, and radical form. Now with a rational exponent, so my first example here, we have 36 to the 1/2 power. This 1/2 is considered a rational exponent because it's an exponent written as a fraction. Now when we have a rational exponent, the numerator represents our power and the denominator represents the root. So if the first thing we were to do is to switch forms, this is a 2. 2 represents a square root. So this would be the square root of 36 raised to the first power. The bottom number, the denominator of a rational exponent, is your root. The numerator is your power. So the square root of 36 is 6, and 6 to the first power is just 6. Okay, example 2. The top number is our power, the bottom number is our root. With a rational exponent, the numerator is your power, the denominator is your root. So 8 to the 2/3 would be rewritten as the cubed root of 8 because this is our root, this is our power. The cubed root of 8 squared. Well, the cubed root of 8 is 2, and 2 squared is 4. All right, our third example. -27 raised to the 2/3 power. So we have another rational exponent. The numerator is your power, the denominator is your root. So we'll take that root first. The cubed root of -27 squared. So the cubed root of -27, what number times itself 3 times is -27? Ignore that bell. That is -3. And -3 squared is +9. Okay, our last example with a positive rational exponent is this one. So we have a fraction raised to a rational exponent, but we still do the same thing. The denominator of the exponent is our root. So we're going to take the square root of 4/9. And then we're going to raise that to the 3rd power. Well, the square root of 4 is 2, and the square root of 9 is 3. So it becomes 2/3 to the 3rd power. So 2 cubed is 8, and 3 cubed is 27. Okay, so we talked about negative exponents already. So we know with negative exponents, they have to move. Well, if we have a fraction raised to a negative exponent, when we move this here, move that there, basically, it's the reciprocal. We're flipping the fraction. So if we have 4/9 raised to the -3/2, the first thing we would do, because there's nothing to simplify inside, is go ahead and write this as the reciprocal to the positive 3/2 power. So that is the square root of 9/4 cubed. So the square root of 9 is 3, the square root of 4 is 2, so it's 3/2 cubed, which is 27/8. So all that happens when it is negative is it becomes the reciprocal, and we can see that here when we compare these two answers. Now, this one, number 6, is not written as a fraction, but it's raised to a negative exponent. So what we do is we think about it being over 1. So when we go to flip the entire fraction, it becomes 1/16 to the 1/4 power. So the numerator is our power, the denominator is our root. So that is the 4th root of 1/16 to the 1st power. What number times itself 4 times is 1? 1 is the only thing. What number times itself 4 times is 16? That is 2. And 1/2 to the 1st power is still just 1/2. Okay, so now this is in terms of a variable, and the reason I switched to this at this point is I want to show you all the different ways where it means the exact same thing. So this x to the 5/2, I could really think of this as x to the 1/2 raised to the 5th. So that's where I take the root first and then I raise it to the power, which is what I've been doing on all these numeric values. And the reason I take the root first, I choose to take the root first, is because it gives me a smaller number. And I like to deal with smaller numbers whenever possible. Now, that's not the only way we could do it. We could raise it to the power first and then take the root. So these are equivalent statements because when we multiply, when we raise a power to a power, we just multiply. And 1/2 times 5 is 5 halves. 5 times 1/2 is 5 halves. So these are equivalent statements. These have the exact same meaning. And all three of these have the exact same value. Now, this one, when I write it in radical form, becomes the square root of x to the 5th. So that must also be equivalent to the square root of x to the 5th. So whether we raise to the power inside or outside, it has the same value. Okay, so these are just equivalent forms. This is written as a product of powers. This is written in radical form. All right, so if we did the same thing here, this would become, the root is the 4th root. So it's the 4th root of x to the 3rd power, or we could write it as the 4th root of x cubed. These are equivalent. Now we could also write this as x to the 1/4 power cubed. This could also be written as x cubed to the 1/4 power. And this is something you could see on SAT, ACT, that type of thing, where you would have to understand that they all are equivalent, that they have the same value. All right, we'll take just a second and let's see if you could write this. Ignore that bell also. I'm recording here at school and it's in between classes. Okay, so let's take a look at these. So here we're starting off with a radical. Let's see if we can go the other way. We've been working on starting with a rational exponent and switching it to radical form to simplify. Now let's start with a radical form and seeing if we can switch it to rational form. So the root is the 5th root, so the denominator would be 5. The power, there is no power, so it's an understood 1. So this is as a radical, this is a radical, and this is as a rational exponent. And those are equivalent forms. All right, here's the radical form. Can we write it as a rational exponent? So what is our root? Our root is 3. What is our power? Our power is 4. Power over root. All right, so let's take a look at this one. If we went ahead and rewrote this, this has this entire expression under the radical. So the 2ab squared is all under the cubed root. Well, the root is 3. The power is an understood first power, so that would be 1/3. Now, is that the only way to write that with rational exponents? No, because we know when we have a product raised to a power, we could take each part of that product and raise it to the power. Whoops, 2 to the 1/3 is 2/3. So this is if we just raise the entire product to the power. So what would this look like? Well, this is kind of interesting. This would become 27, a to the 6th, b to the 9th, and because this is cubed root, it would be the 1/3 power. Root power. Okay, so this is 27 to the 1/3, a to the 6th to the 1/3, 6 to the 1/3, b to the 9th to the 1/3, b to the 9th to the 1/3. Well, what is the cubed root of 27? The cubed root of 27 is 3. And then what happens here with the a? 6 times a third is a squared. What happens to the b? 9 times a third simplifies to b cubed. So, thinking of this as a product raised to a power can help us to simplify. So we should always work through that process to see if there's anything we can simplify. Okay, now on this one, everything simplified. Sometimes parts simplify and other parts don't. So here we have the square root of 25x to the 6, y to the 5th. So this is the square root. The square root is the same as the 1/2 power. So this becomes 25x to the 6th, y to the 5th, which if we think of this as a product raised to a power, this is 25 to the 1/2 power. Half of 6 is 3. Half of 5, well, that doesn't divide so evenly. So what happens when it looks like this? Well, this can simplify some more. 25 to the 1/2 power, the square root of 25. What is the square root of 25? The square root of 25 is 5. And then we have x to the 3rd. And then here, do you see that 2 goes into 5 2 times? So 2 y's come out, and there's 1 left over. Now we've done some simplifying before. We did it straight from here. We said the square root of 25 is 5. The square root of x to the 6th is x cubed. Okay, now if I thought of this as y to the 4th times y to the 1st, we can take half of this one, but 1 has to stay under. So we get the same thing, but we can think about it as a product of powers. Okay, now this one, the cubed root of 48, a to the 10th, b to the 12th, c to the 14th. Cubed root this time. So cubed root is the 1/3 power. So when we're trying to think of this as the 1/3 power, 48 is 6 times 8. Now I chose 8 because 8 is a perfect cube. So if I'm trying to simplify this, I look at this number and I go, okay, are there any perfect cubes that are a factor of 48? And it is 6 times 8. All right, so this becomes a to the 10th, b to the 12th, c to the 14th. Nothing happened yet. Okay, so when we break it up, we get 6 to the 1/3, 8 to the 1/3, a to the 10/3, b to the 12/3, c to the 14/3. All right, so this is helpful. I can take the 1/3 power. I can take the cube root of 8. The cubed root of 8 is 2. I cannot take the cube root of 6, so it has to stay under the radical. 3 goes into 10 3 times, so 3 come out. But how many are left over? 1. 3 goes into 12 4 times, so 4 b's come out. And there's nothing left over, so there are no b's left under the radical. 3 goes into 14 4 times, but there are 2 left over. So this is one way of using the idea of a rational exponent here to help us simplify our radical. Okay, so let's take a look at where you're doing practice. The first thing you're going to do in part 2 of the worksheet you received is rewrite as a square root and then simplify. So all of these are not square roots. It should just say as a root and simplify. Make sure you don't have any negative exponents in your answers. Now, this part 3, I really want you to do two things. I want the rewrite using rational exponents to be part A, and then part B, I want you to write it in simplest radical form. All right, so let me do number 11 with you. So for part A, you can see what's happening. If we just rewrite this as a rational exponent, the power, for number 11, A, the power is the numerator, the root is the denominator. Done. That's as a rational exponent. But if you're asked to write it in simplest radical form, that's where you would say, okay, 3 goes into 7 2 times, and there's 1 left over. So 1 stays under the radical. So this is simplest radical form. This is as a rational exponent. So rational exponent is really easy. You just do the power and the root. Simplest radical form is where you have to take this idea to simplify the radical. If you have any questions, let me know.